Mesh MEA is a new type of microelectrode array chip that is optimized for organoids. Traditional two-dimensional MEA chips cause organoids to flatten and deform and can only record data from the outside of the organoid. With the Mesh MEA, the organoid grows around the microelectrodes and maintains its shape over a much longer time. This allows long-term recording from inside the organoid, providing valuable data on its development and behavior over extended periods.
I am excited about this new technology because the organoid slowly sinks over time into the mesh. This allows the cells to move around the electrodes and does not damage the cells like slicing or needle insertion. The capability of the Mesh MEA to allow recording from the inside of the organoid will enable us to record from functional entities within complex model systems like brain organoids and advanced cardiomyocyte organoids that recapitulate the layering of the heart wall.
If the Mesh MEA isn't sterile, the first thing is to disinfect it. This can be done by putting it in 80% ethanol for 30 minutes. Ideally, to allow the ethanol to wet every part of the Mesh MEA, a prior plasma treatment is advised, but not necessary. After 30 minutes in ethanol, take the Mesh MEA out and shake it until larger residuals of ethanol, especially below the mesh, are gone. Then place the Mesh MEA on top of a fresh and sterile petri dish to dry for at least an hour. The Mesh MEA can now be coated as needed. To avoid medium evaporation, a sterile filter paper with the hole in the middle is placed in the petri dish before the Mesh MEA is added on top of it. The paper is then wetted with 1 mm of sterile water. To fill the Mesh MEA, start by adding medium to one of the two inlets to fill the space below the mesh. Then, either continue adding medium through the inlets or add medium directly to the well. To remove air bubbles below the mesh, take the petri dish with the Mesh MEA and tilt it so that the bubbles float to one of the two inlets. From there, with a 200 microliter pipette tip, carefully aspirate some of the medium together with the bubbles. If the total medium amount is crucial, aspirate the bubbles and all medium above the mesh. Then add the missing medium amount. To avoid air bubble formation, doing a partial medium exchange might be the better option. For this, remove all medium above the mesh from one inlet until the medium in the other inlet starts to drop. Then with a new pipette tip, get fresh medium and add it from the previously used inlet to the Mesh MEA. To do a full medium exchange, first remove all medium from the Mesh MEA. Then slowly add the desired medium amount. If bubbles form, remove the bubbles by tilting the Mesh MEA and aspirate from the higher inlet until the bubbles are gone. Before placing cells on the Mesh MEA, fill a space below the mesh with medium. With a pipette, aspirate the cells with as little medium as possible. Carefully place the cells onto the electrodes. Remove excess medium from one inlet so that no medium is above the mesh, and the cells are only covered by a medium film. Place the Mesh MEA in an incubator for 2 hours before adding additional medium to cover the cells. When recording at multiple time points, place a MEA mem on the Mesh MEA to maintain a sterile environment. The Mesh MEA can be recorded using a suitable device such as the MEA Mini. Before recording, carefully clean the pins of the MEA Mini with isopropyl. Then gently remove the Mesh MEA from the petri dish and place it on a tissue to dry the bottom. Clean the measurement pads of the Mesh MEA with isopropanol and place it in the MEA Mini. After closing the MEA Mini, seal it with a lid that has an active carbon channel supply.